Okay, so let's look at our last counting rule, which is the combinations rule. So the combinations rule is different than the permutations rule because order doesn't matter. So recall the permutations rule is only used when order matters. Okay? Order matters in the permutation rule. But in a combination is a set of n objects taking r at a time. There's any selection of R objects where order doesn't matter. For example, how many groups of 3 can be selected from 5 items labeled A, B, C, D, E? Well, we know there's 5 ways to select the first item, 4 ways to select the second item, and then 3 ways to select the final third item. So it looks like there's 5 times 4 times 3, which is 60 possible ways uh, you can select 3 from 5. But where order, okay, so but note that uh, so the group say ABC, okay, is the same as the group ACB, is the same as the group BAC, the same as the 3 BCA, right? Is the same as the group CAB and CBA. But these are just chosen in a different order, each of these, right? But these represent the same group of 3 letters A, B, C. Okay? So the 3 items A, B, C is actually counted. This is where order matters, right? But when the order matters, that means we uh, count the subgroup A, B, C actually 6 times. We count it 6 times. Okay? So then the number of groups that can be 4, where order doesn't matter, like how you pick it, is the number of ways you can select 3 items from 5 divided by the total number of repetitions of each of the 3 items, right? The ways you can order the 3 items. So that's 3 factorial. Right? So so it'll be in fact this will be equal to 10. Okay? And you can actually write this as 5 factorial over 3 times 2 factorial. Okay? So then we define the number of different groups of R items that can be selected uh, of n items is n choose R, or n choose R like that, which is n factorial divided by R factorial over n minus R factorial, where order doesn't matter. Okay? Order doesn't matter. So for example, a committee of 3 is to be selected from a group of 20 people. How many different committees are possible? Well, in this case, order doesn't matter because you just want to form a committee of 3, no matter which order you select them from. So just 20 choose 3. Right? So 20 choose 3 is just 20 factorial over 3 factorial times 20 minus 3 factorial. Just, 20 factorial over 3 factorial, 17 factorial. So just write this out. Is 20 times 19 times 18 times 17, right? All the way down to 3 times 2 times 1. 17 factorial is like 17 times 16, all the way down to 3 times 2 times 1. B factorial is 3 times 2 times 1, right? So you can cancel this latter part with this part, 17 factorial. Right? So all you're left with is 20 times 19 times 18 over 3 times 2 times 1. You can cancel more things out. 3 cancels with 18, you get 6. 2 cancels with 20, you get 10. So 10 times 19 times 6. In the end, that will be 1140.